All right, Gen Chem class, it is Wednesday, December 6th. Today, we're going to start with a quiz. I let you know about that yesterday. If you have anything to turn in, maybe throw it in the folder. Otherwise, take 5 minutes. All right, seems reasonable. If you need to look over notes, it's over alkanes and branched alkanes. All right, and isomers. So those are the two things it's over. Pretty straightforward. There's no alcohols, halocarbons, aldehydes, ketones. Okay, so branched alkanes and whatever the other thing I said, isomers. Okay, so take some time to look at that. Sub can probably pause the video, and once you've had 5 minutes or so, the sub will pass out the quiz. Take the quiz. All right. If you could bring it over to the sub, or bring it to the sub if the sub is at the front, and if the sub can just put like a paper clip on them, just keep them on my desk, and I will grade them when I get back. So anyways, you can just collect them as our quizzes. That'd be great. So do that while the quiz is going on, while reviewing quiz. Pause the video. Our lab is not terribly long today. It takes a while to set up, but just pause the video. Once everybody's settled after that, I'll talk about the lab. All right, so we are back. All right, so if the sub could pass out this document, lab chromatography. All right, pass that out. If you need to pause it again, go ahead and pause it. All right, once that has been passed out, each student needs one piece of, it feels like coffee paper, but it's called a chromatogram. So if you can pass one of these out to each student as well. All right, so we are back. So on the lab, again, lots of setup. But the lab itself, once you're ready to go, doesn't take that long. So everybody is going to have their own chromatogram. This is how I know that you did the lab, okay? So don't do this with a neighbor. Everybody has their own chromatogram. All right. So really quickly, I'm going to read the purpose. It's going to help you out as you answer questions. Like all chemicals, inks have different physical properties like boiling points, melting points, and color. These properties can include the affinity or the attractiveness of a dye to a particular chemical. If a chemical sticks to another, it has high affinity. It's highly attracted. If a chemical doesn't want to stick to another, it has low affinity or low attraction. If we have several dyes with different affinities to a single liquid, we can separate them with a technique called paper chromatography. In this lab, we'll be separating various inks used to make colored pens and markers. So again, at your tables, you should have a little bin that has 10 pens and markers in it. The general rule of thumb is like attracts like when it comes to intermolecular forces. Okay. In other words, polar solvents, something that has really, really strong hydrogen bonds, is going to attract inks with really, really strong hydrogen bonds. So polar solvents attract polar molecules, non-polar molecules attract non-polar inks. Okay, and vice versa. So we can tell the strength of an intermolecular force by the liquid we are putting, are causing our ink to smear in or run in. Okay, so here's kind of what you're going to do. Okay, so the setup, just go with me. All right, if the sub needs to pause stuff, ask the sub to pause it. Okay, so procedure, mark two identical pieces. You're gonna have one each, okay? So you and your lab partner are going to put them in different solvents. One of you is gonna use water, one alcohol. Don't worry about that for now, okay? So each person has one, and you're gonna staple your one chromatogram to your page. So I know that you did the lab, okay? So everybody has one of these, not two, but in a lab, like in a shoulder-shoulder group, one person will use water, one person will use rubbing alcohol. Okay, so with a pencil, only use a pencil. Otherwise, your name is going to smear. Go ahead, kind of like this has, put your name in the top left corner. So I'm going to put Burkett. And then in the top right corner, don't worry about period and stuff like that. In the top right, you're either going to put water or alcohol. Okay, so just between you and your partner, decide who's going to do what and write either water or alcohol. So there's what mine looks like, Burkett's, and I chose water. All right, next. This graphic is wrong. Okay, it's not completely wrong, but it's wrong enough. So this sheet of paper is 10 centimeters by 5. That's good. Notice it has a little thing that says pencil line should be 1/2 centimeter from the bottom. Right here, the point of origin line should be 1 centimeter from the bottom. So at your tables, you should have rulers. Okay, so use the centimeter side, and what I would do is I would look at 1 centimeter from the bottom. Okay, on both sides of your chromatogram. So I'm going to do it on the left side. I'm also going to do it on the right side. So notice I've got to mark 1 centimeter from the bottom there, and I got to mark 1 centimeter from the bottom there. Okay. Next thing I'm going to do, I'm going to use my ruler, and I'm going to connect those two lines with just a faint pencil mark. Okay. So just so that you can see it go across. So you should have a pencil line 1 centimeter from the bottom that's parallel to the bottom of your chromatogram. Okay, so you might pause that and let everybody get that part done. All right, so next, okay, this has this little thing, but students ignore it because it's equally distributed. It's like, notice the gap on the left side of the one is the same as the gap on the right side of one. But notice down here it says the first and last numbers are 1/2 centimeter from the edges. All right. So we want to put 10 inks across the bottom. This thing is 10 centimeters long. So if I start with 1, I mean, 10 would not be on the edge, but 1 is going to be on the edge of my page, which means it's not helpful for me. So what you want to do is, with your ruler, is I would set, I'm not sure that you'll be able to see this on the camera, but I would set your ruler so it's 1/2 centimeter off the edge, okay? And when it's 1/2 centimeter off the edge, you should see all your numbers 1 through 10 are going to fall somewhere on the line you just drew. And we're just going to do like a little vertical line just to show where I want to put my inks. So they're 1 centimeter apart, like equidistant apart, and there's 10 of them from left to right. So if you start 1/2 centimeter in, you will have space for 10 lines across. So again, just kind of mark them. Should be 1 centimeter between, but start 1/2 centimeter from the left, and you should end up with 1/2 centimeter on the right. So again, you might pause that while students finish that up. All right, so next, you should have 10 inks in front of you that are basically these. So you should have a black Sharpie. I think everybody has a black Sharpie. You should have a black vis-a-vis. Black and it says vis-a-vis on it. You should have a black ballpoint pen. You should have a green marker. So like a marker like this. And then you should have a green ballpoint pen. Yellow or red Sharpie. Okay, so this one happens to have a yellow Sharpie. Some have red Sharpies. I didn't have enough. A blue ballpoint pen. A purple ballpoint pen. Looks like this one's actually pink instead of purple. But purple or pink. Does it have ink in it still? I don't know, that ink might be gone. Check that one. And then you should have a red marker and a blue vis-a-vis. Okay? So there might be some slight variation, but you should have things like that. Okay? So what I would suggest is on your page, okay? Here's where we're headed, and then here's why I think it's important. I don't care what order you go in. You can go in this order, great, okay? But you need to know the order you go in. So I just happen to grab the red marker out. So I'm going to put a red dot, okay, on that first little space I have, okay? So on my lab, okay, I'm going to take a pencil or pen, really doesn't matter, where's my pencil, and I'm just going to say number 1 was red marker. Red marker. And I'm going to set my red marker off. I've used it. I take it out of the cup. Okay. My next one's going to be my black ballpoint. And then I'm just going to take some ink, get it on my sheet. Okay, so you might use your black ballpoint just on your lab, let the ink flow. And now I've got a dot of black ink on my second thing. And I'm going to do number 2, black ballpoint. I think it will be helpful if you and your shoulder partner do the same order. You don't have to, but you're going to compare both yours together on one of the questions. At a table of 4, you don't have to all do the same order, but I think it'd be helpful if you and your partner did the same order. So what I would do, as you put little ink dots across the bottom, make a key as to what order you're putting them in, okay? And just make sure you have all 10 used. You're not like globbing on a bunch of, like, don't hold the marker there and let it bleed like crazy. Just put a little dot. Ballpoint, just put a little ink there. Okay? So again, at this point, you might pause it. And I'll leave, pause it with the types of ink up there just so they can see all the 10 they have. And then I'll be back in a sec. All right, so hopefully we are back. You've got more than I have. I've only got 2 dots there, but you should have 10 dots across your piece of paper, okay? So you go ahead and flip your lab to the back side, okay? And I'm gonna go back to my lab sheet. And I'm gonna scroll down to the next page and scroll over. All right, so now what's gonna happen is, I'll have the sub bring these around, but I've got these fancy-dancy staplers. All right, they're shaped like this because what's going to happen is you're going to fold your piece of paper into a cylinder, okay? The important part is the bottom needs to be as flat as possible. And if you look at the picture, you don't want to overlap your pieces of paper, okay? So notice I've got a gap in my paper, and I'm going to stick the stapler in here and staple the bottom, and I'm going to staple the top. Again, leaving a gap in your paper. So notice my paper at the bottom has a gap there. I should have left a little bit bigger gap at the top. So again, I'm not sure how that's focusing on the camera. You should see a little gap there, okay? So each table should have a stapler. You're only doing one per person. If I was here, I'd have you do 2 per person, but you only have 1 of these. So pass the stapler around, staple stuff up. All right, so at your labs or at your tables, we're just doing it with tables. You should have 2 little weigh boats. Okay, one says alcohol, one says water. Additionally, at your table, you should have a bottle of isopropyl alcohol. You should have a beaker of distilled water. Okay, so and they should each have a pipette in them. So essentially, this is super important. So you want to put enough liquid to cover the base. Don't like fill it. I mean, you don't want to fill it, all right? So you want your liquid level to be below the line of your pencil line, all right? So notice in this picture, see how the ink is above the water level, okay, or above the alcohol level. So enough water to cover, and then as horizontally or as perpendicular as possible, you're going to set the water, or if you have the water one, you're going to set it in the water, and it's just going to set there. Okay, alcohol person, put isopropyl, just enough to fill the bottom, set your paper there, okay? These are gonna start developing, all right? And by develop, once your water is gonna get sucked up the paper, all right, due to capillary action, that's a word you might remember from biology last year, and it's how trees and roots take up water and take them up their trunks, okay? So the water's gonna travel up. Water has really strong intermolecular forces. It's really hydrogen bonding, so it has very polar. So if colors are moving with the water, it means those inks have strong hydrogen bonds like water does, because like attracts like, all right? Alcohol is still polar, but not nearly as polar as water. Alcohol is more like London dispersion. It has much stronger London dispersion than it has dipole-dipole. So it's closer to nonpolar. So what you're going to see when you compare these two is the way your inks bleed should be different in the water and in the alcohol, okay? Here's when you're going to take them out. So notice you had a centimeter from the bottom. Once your colors get a centimeter from the top, take them out, because what's going to happen, this paper has enough water in it. Even when you take it out of the water that's just at the bottom is going to keep on running to the top. So eventually your water is going to hit the top. The alcohol, just from past experience, it might get halfway up the paper and it's just going to stop. Just gravity becomes stronger than the capillary action for the alcohol, because alcohol is a much heavier compound than water is. All right. So anyways, after that, all right, I would just take them out. Probably take these back to sinks and dump them out, just so we don't have liquids that can get knocked over for next hour's quizzes. But you got questions on the right-hand side. Yeah. Probably 2 you can answer without doing any, just with background knowledge. The last one I want to talk about is number 7. Okay. RF is retention factor. Okay. And it is talked about on page 1 right here. So the distance the solute travels, and the solute is the ink. And we're going to take the distance the solute travels. Again, you have rulers at your table, right? So how long did the solute travel compared to how long the water traveled, or to how far the alcohol traveled? All right. So notice what the question is this: using the green marker. So the green marker in the alcohol, okay, and I only care about the yellow ink in the green marker. So the green marker is going to have a yellow band to it. All right. So I want to know how far the yellow moves and how far the liquid moved. And it's just a number over a number. It should be a decimal: 0.75. 0.62, 0.43. So just have a number divided by a number, simplify it, and just write down what decimal number your calculator gives you. Okay? That is it. When you're done, notice right here, staple chromatograph here. All right? So kind of at the end of the lab, this is going to be kind of wet. Just kind of rip your staples out. Okay? Kind of just flatten it out. Set it there. You've got a stapler. It can go pretty deep into the paper, and just boom, staple your chromatogram onto your lab. And that is it for the day.